We're solving problem 13 from the 2023 F equals MA exam. A uniform box with mass m is at rest on a horizontal surface, and the coefficient of static friction between them is mu of s. A force directed at an angle of 85 degrees above the horizontal is applied to the center of the box with a linearly increasing magnitude F equals beta times time. The box will eventually slide or lift off the ground. Which of the following is correct? So we have this box here, and these are all the forces that's acting on it. We basically want to determine the how long it takes to lift and how long it takes for it to slide, and we want to compare those two, but not necessarily find their values. So for lifting, this can be denoted by f of t times cosine of theta, and that has to be equal in magnitude to mg. And since we are given that f of t is equal to beta times time, we can plug that in to get beta times time. In this case, times cosine of theta is equal to mg. So we can solve for the time variable, and to be specific, we'll label it time of L for lifting or liftoff. And this is just equal to mg over beta cosine theta. Okay, now let's work on the sliding. For the sliding, we know that the force here, f of t times sine of theta, now because it's at an angle, has to be equal in magnitude to the static friction here. So that's mu of s times the normal force n in this case. But since the force is angled, we have to, this n can be written as mg, the force pulling down on the block, and then subtract f of t times sine of theta. We can then again plug f of t is equal to beta times time into this equation. So this is beta times time sine of theta is equal to mu of s times mg minus beta times time sine of theta. So now what we want to do is we want to make this as easy for us as possible. And since we see that this term on the inside has beta and time, we want to multiply this out to move it over here. Once you've done that, you get that, and you can factor out the beta times time. This is beta times time times sine of theta, and then this is plus mu of s times sine of theta. And this is equal to these two when you multiply it out, which is mu of s times mg. Now you want to isolate our time variable here, so you can do that by dividing both sides by beta times sine of theta plus mu of s times sine of theta. So, and let me be clear, this is sliding. So t of s, which is slide, is equal to mu of s times mg over beta times sine of theta plus mu of s times sine theta. And then you divide like that. So what's interesting here is that we can incorporate our equation for the lifting of the time here, because we can factor out an mg over beta sine theta from this equation. So once you do that, this becomes mu of s over sine of theta plus mu of s cosine theta. So once you have done, and then this is just time for liftoff. This shows that that it's longer or shorter for the lifting off to occur, as it has to be incorporated into this formula. It's got to be more because you're multiplying it across. So in this case, we can find out that the box would slide first for any value of mu of s, the static friction. So that correlates to answer choice D on the test.